Hey everyone, this is Tired Goth, and you are watching one of my tech shows. This is the Computer Show, episode 71. Feel free to invite your friends, join in, share the live. I love good attention. So, yeah. I'm actually going to invite a few of you in here. G7, thank you so much. Thanks for being here. Thanks for supporting me. Thank you for always having my back here. I love you all. Thank you to everyone who's ever come to my readings as well, because y'all are great. Okay, so we're going to talk a little bit about why everyone has been fighting over why we need more programming languages or why we don't. So I don't know if anyone realizes that anything that you want to do with a programming language can basically be picked up in a regular text document. So basically, if you're just writing a notepad and deciding you want to write some code, you can basically just do that in the notepad if you have the skills to do it. If you know how to type in programming language syntaxes, you can basically just type up the entire document as you want to and then compile it. You would just save it as a file extension that would be able to be compiled into that language. So for example, if you were typing a Python document as opposed to an HTML document, which are two different things in case you didn't know that, you would be typing .htm or .html or even .txt for the HTML file. And if you wanted to compile it into a Python document, you would type .py for Python. You would be doing this to assure that whatever programming languages you were using were actually going to meet the expectations that you had for the language, for the code, for the instructions. Because that's what programming languages are, they're instructions. So if we can settle on the fact that anything written as an instruction in a text editor, no matter which text editor, so I don't know why you're fighting about that either, but I'm just going to stay out of that. You can do anything you want to. So what this really means is if you're using a programming language or you're not, you can basically just type all of that regardless into a text editor to see what it does. It's really simple. So there have been arguments as to how much space a programming language or a text editor takes up. And that's the argument for why things would be used or not used. So what you have here is a discussion of what file types are being saved, how much space they're taking up, and who is fighting over this for the grand scheme of amassing pretty much any data amount, big or small, arguably the largest. So what we're looking at, like a Googleplex of data, right? This is what people are arguing about. And the reason why they're arguing about it is because each of those characters that you type into a text window has a byte size that represents a bit size. So while these sound the same, they're not the same. A byte is actually, if I'm not mistaken, 1,000 bits? Yeah, about 1,000 bits, right? So a byte has 1,000 bits. Now, what do you do with 1,000 bits? Well, on its own, kind of, sort of, nothing, because they're supposed to be allotted to storage that is inherent to the PC, the device, or the chip that is storing them in certain storage compartments. You will find them in the device's operating system or the kernel, wherever it decides to lodge itself. So you have this going on, and then you also have the amassing of this information in the storage to then create characters or analyses of characters once they've actually presented themselves. So when you have bits and bytes together, you have 1,000 bits that make a byte, and then you have however many bytes make up a kilobyte, right? That's about 1,000, right? And then you have megabytes, which are 1,000 kilobytes, and about 100,000 bytes, and so on and so forth. And it goes on to explain these things in the amassing of this data and where it is stored. That's essentially what we're looking at when we talk about the difference between bits and bytes. However, people have argued that the sizes of bytes used to formulate a script is usually too high and that running the script will take up too much RAM. This is a matter of argument for downsizing the amount of cached data that would be represented and thus needed to be cleared out afterward, after coding and writing these things together. So supposing you compile a Python document, you want it to do XYZ. You might make a magic 8-ball Python document that runs a magic 8-ball yes or no question document, right? And I'm saying document because I know it to be a document, but the way that it's going to run for you once you compile it is like a game. You would type out a string, or a set of strings in this case, to create a game in Python. And you would press your options to control whatever it is you wrote, and then turn it into your brand new thing to ask yes or no. And it would run for you. It would be an ASCII. It would be art that supports a non-graphical thing outside of text, but you would still have a program that runs it. The thing is, your Python document at this point may run a few dozen megabytes, maybe, right? And this is the reason that people are arguing, no, it's the text editor and the file sizes that are compiled that result for the text editor cache, I should say, and then the files cache sizes that result from being programmed in a certain language. So if you're typing in Python, you may get a certain file size as a result of your script. Whereas if you typed it into HTML or PHP or CSS or, I don't know, if you typed it into another language like Golang or something like that, or C++ or C#, or something that was more a Haskell language and less a big data language like Python, you would have different results because you would have to physically type a lot of the hard-coded information and thus take up byte space for more strict instructions and coordinates for the data. Meaning, if you actually have a file size that says, you know, do this, this, and this, but do this, 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 and this, and like it rattles on the instructions for about 4,200 characters, as opposed to what Python would do, which would be calling from a library and saying, do this, this, and this. And those three instructions kind of culminate together what a C language would be doing. Theoretically, it sounds like a better use for the case, right? It sounds like a better idea. However, what people aren't realizing is if you don't itemize certain things and specify certain things for larger and more significant projects, the byte sizes stop mattering because you don't have enough specifications to secure your program. So sure, Python might be cool for putting around with games, you know what I mean? But what you actually want is something that represents more so what it is that you would be doing if you were securing your data. So which language would it actually be that you would prefer to use despite the size that you would be looking for to downsize the use of the cache data, right? So this is kind of where these programming languages come into a tiff with one another, because people will argue that, no, this is the better language for this if you want this result, and so on and so forth, because there are more specifications and you can call different libraries and blah, blah, blah. But it's actually not always so cut and dry, because if you are trying to run something like a server and you need extra security for that back end of a server, you're not going to want to rely on a lot of the languages that are commonly used, like Python, for these things. Even Ajax, Google, and I should say Google, like Go language, right? Which is, if I'm not mistaken, a REST API-based language, a REST API-based language. And it has less, I guess you could say, inference to how specific it is. Like, you can do more with less strings in Golang and with the REST API in general. However, this is also a recent thing. REST API only came out within the last decade or so, where a lot of languages that were already being utilized were different and maybe did not put together as much. So it kind of, there was like a sort of, do I stay or do I go with the kind of language that was available at the time, which was largely Python, C, C#, and so on and so forth. REST API brought out a lot of really cool stuff, but it didn't necessarily change the fact that Google is also highly unreliable for the fact that it will sell your data to just about anybody just because it has it. So we want something that's organic, really. So a lot of people have actually gone back to HTML for most of the stuff that they would have been relying on more fanciful programming languages anyway, sort of like CSS and PHP. And apparently PHP doesn't actually know itself. So that's a whole other thing that people are now discovering. So it's sort of like, well, what do you do? But yeah, in the case that you would like to try some of these languages out for yourself, I would recommend going all the way back to 1974 for a copy of James S. Cohen's textbook called Basic Basic, where you basically learn, no pun intended there, how to type entire strings of what is considered to be a Haskell language or a hard-coded language that brings to you everything that you would need to structure your varied inputs for these things, meaning that you would be hand typing each of the values that you expected to be in this text document to get a better understanding of how lucky and blessed you were to be coding in Python in the first place with the greatest of ease and not necessarily knowing how to actually structure your data in the first place. This has been Tired Goth. I love you guys. Thank you for joining me at the computer show with me, and I'll catch you guys later. Bye.